Alright, so here's a polynomial, an x to the fourth degree polynomial. We want to solve this, so I have it equal to 0, and we want to end up then writing it in fully factored form. So our first step is going to be to graph it and find, if any real zeros. So here's the calculator, and I've already graphed the function for you. And if I press graph, I can see that it crosses the x-axis 2 times, even though it's a fourth degree polynomial, so I see 2 real zeros. Let's look in our table, second graph, and if you have a 0, an integer 0, that means your y-coordinate is 0. So look, there's a 0 at -3, and there's also a 0 at 1. So let's write that down. So we have a 0 at -3, and we have another 0 at 1. So I'm going to do the same technique I did the other day with synthetic division. I'm going to pick one of these zeros to start. I'm just going to pick the -3 just because it's the first one, and I'm going to write the coefficients of the polynomial right up here like this. Okay, and then I'm going to do the synthetic division. So this is -3, adding up is -1, +3 adding up is 4, -12, adding that up is -4, 12, 0, which I expected, of course. This is my resulting polynomial. So this would be x to the third minus x squared plus 4x minus 4. Now, what I'm going to do is do synthetic division with the next 0. And there's my coefficients right there. So I'm ready to go right into the second synthetic division. Drop the 1. 1 times 1 is 1. Adding them up, there's 0. 1 times 0 is 0. Adding them up, it's 4. This is 4, 0. And there's my remainder, which is 0, which is what I expected. The resulting polynomial here is x squared plus 4. And inside this are my 2 complex zeros. I know they're complex zeros because they didn't show up as crossing the x-axis. So I'm going to set this equal to 0 and solve for those. Let's do that over here. Subtract 4 from each side. So we have x squared equals -4. Square root each side. So you get x equals plus or minus the square root of -4. So that becomes plus or minus. The I is under the, the negative is under the radical, so I can pull that out and make that an I. And the square root of 4 is 2. So here's my solutions. X equals -3, 1, and plus or minus 2i. Let's also write it in the fully factored form. So I have x minus the 0, and x minus the 0, and x minus the 0, and x minus a minus is a plus 2i. So here's a case where I used synthetic division twice with each of my real zeros, and every time you do a division problem, you're reducing the degree of the polynomial. So when I started with a degree 4 and I did my first division, this is an x to the third. I just didn't need to write it out because I knew I would go directly into my second division. And then when I did that, I ended up with an x squared. So there's 2 solutions in here, and both turned out to be complex. So this is the end of the first example.